Practical work is really important in physics. Yes, you can get by with strong math skills or a really deep understanding of the theory, but the practical work just ties things together and makes it really mean something. So, it's something that examiners are going to want to examine as well, to test you on. In IGCSE, we do it by looking at a physical paper. You're not actually going to do any practical work, and that makes the questions a little bit odd sometimes. So let's have a look at an example. Here's a picture of a variable potential divider. Actually, we can call this one a potentiometer, as all it's really doing is letting us measure a voltage. In a test, the circuits you see are not necessarily useful. They just let the examiner test your understanding. So there's a 2-volt power supply connected to a piece of resistance wire on a ruler by the looks of it. One side of the voltmeter is attached to P. The other has what's called a jockey that can be moved anywhere on the wire. The other end is labelled Q, and there's an ammeter and a switch finishing off the circuit. So she's going to put the jockey in 3 positions to get results. Around here, here, and here. First off, we need to complete this table. Remember that I want you to play along when I ask you a question, so have a quick think about the headings. The headings should be simple enough. M, V, A, and ohm. Technically speaking, it should be okay to write V over A for the resistance unit, but it's not really the best thing to do, so don't. Do be careful though that you are reading the text to see this is meters, not centimeters. They give you the equation because this paper is not really trying to test your electricity knowledge, only your ability to do practicals. So, R equals V over I, 0.54 over 0.32 equals 1.6875. How many of those numbers should I be writing down? 1.6875. How many sig figs should I have? Now a good rule of thumb at this level is to go with 3 sig figs, and you would get the marks. That's what I'm going to write here. I'll add a quick bonus video to explain another option if you want, but I suggest you just stick with 3. So we have 1.69, 3.44 and 5.03. Now we look at the relationship. It's fairly clear from the table that as length increases, resistance increases, but we need more than that to get 3 marks. The question clearly states to use numbers from the table, so we need to calculate something. It looks pretty linear, but is it proportional? Actually, what is the test for something being proportional? How can you tell if the results in this table are proportional or not? Have a think, commit yourself. If you said that the graph is straight and goes through the origin, that's not bad, but not actually right. That is going to be true, but to test if something is proportional, we need to do some maths. So what do we do? Remember to pause to give more thinking time. Well, we look at the equation of a straight line through the origin, which is y equals mx. If the gradient is constant, m equals y divided by x, so y divided by x is constant. The ratio of y to x is constant. So what we are saying is that for 2 variables to be proportional, their ratio is constant. Let's test. Let's find the ratio of R to L. I'll squeeze another column here. 1.69 divided by 0.25 is 6.76. 3.44 divided by 0.5 is 6.88, and 5.03 divided by 0.75 is 6.71. Well, they're not the same, but they are not very different either. What to do? Well, they're clearly within 10% of one another, so I'm going to say that R is proportional to I, within the limits of experimental accuracy. The ratio of R to I is constant. By the way, to check if they are within 10%, just take the lower value and multiply by 1.1. If the result is bigger than the other value, they're within 10%. Now they want us to predict. We worked out that R is proportional to I, so all we need to do is extend the straight line on the graph. Or here, look at the table and do some multiplication. We have a value of 0.75 and they want 1.5. So all I'm going to do is write down L equals 0.75, R equals 5.03. Therefore, L equals 1.50, R equals 2 times 5.03 equals 10.06 ohms. If it wasn't so simple, I'd do this since the ratio is constant. R1 over L1 equals R2 over L2. So 5.03 over 0.75 equals R over 1.50. Rearranging that gives us R equals 5.03 over 0.75 times 1.50, which is equal to 10.06 ohms. Finally, we have a question relating to accuracy, but it's a little bit tricky. What will the effect be of changing from 2 volts to 12 volts? What will the effect be? I've got 4 good ones. How many can you get? Let's start by saying the measured current and the voltage will go up. That only counts as one answer. With more current, the third thing is the wires will get hot. Because of that, the wires will expand and the resistance will increase. That's my favourite A-star answer, by the way. Resistance will increase. They'll also accept as another option that the meters might get damaged or even the power supply, which I think is being a bit generous, to be honest. Hopefully that detailed explanation will help you to approach these sorts of questions. The key things are to read the question, read the diagram, and to answer with sufficient detail.